All right, 5.5, which is on properties of parallelograms. So we have these four properties right here. The opposite angles of parallelograms are congruent. So we're going to add that to my picture. So these two are congruent or equal, and then these two are congruent or equal. Consecutive angles of a parallelogram are supplementary. So remember consecutive would be ones right next to each other. So these add to 180. Okay, these would also, these two, and these two. Okay, so those are all supplementary. All right, I'm just going to move these out of the way. Then, opposite sides of parallelogram are congruent and parallel. So these are congruent. These two are congruent, but these are also parallel. And these two are parallel. Okay, and the diagonals of a parallelogram bisect each other. And so they don't bisect the angles, but they bisect each other. So that makes this part congruent to this part, and this part congruent to this part. Okay, four properties of parallelograms. Let's do some problems that are going to use those. So here we're given side measures, and we want to find x and y. And I know that my opposite sides are congruent. I see here that I use x and y, so I need to solve for x first. So I'm going to set 6x plus 3 equal to 15 minus my 3. 6x equals 12, so x equals 2. I'm going to plug that in up here, and I get 8 minus 2y now. So 8 minus 2y equals 2. I'm going to subtract over my 8. So negative 2y equals, we get 6. Make that a negative 6. Divide both sides by negative 2. So y equals 3. All right, here I see that I'm dealing with some angles, and I have some opposite angles, and I have some consecutive angles. We're going to need to find y first because there's only one x and there's nothing in angle D, so I can't set that. My opposite angles are congruent, so I'm going to set these two congruent to each other, my y's. I'm going to subtract y, and I'm going to add 40 all in the same step. So I get 50 equals y. So now I know what my y is. So now I can use that to help me find my x. Now I only have one x up there still, but I do know that my consecutive angles are supplementary. So I'm going to use these two. I'm going to plug 50 in for y, so that makes this 60. So now I can say 4x plus 60 equals 180. I'm going to subtract my 60. So I have 4x equals 120. So x equals 30. So in this picture, I used both the idea that my opposite angles are congruent and my consecutive angles are supplementary. All right, this picture here is going to have us use our diagonals and the fact that our diagonals bisect each other. So I'm going to solve for x first. So my diagonals bisect each other, so this portion is congruent to this portion. So I can set them equal to each other, and I can solve for x. So I'm going to add 4x to both sides, and I'm going to minus 4 to both sides. So I get negative 6 equals x. Now, you're going, oh no, I have a negative number for x, but remember, I'm plugging it back in. So if I have here, I have negative 4 times negative 6, well, that's going to turn into a positive number. And here I have negative 3 times negative 6. That's going to turn into a positive number. So it's okay for my x and y's to be negative. It's not okay if I end up with distances that are negative or time that's negative. Okay, so now we're going to do the same thing for y. This side is congruent to this portion. So 3y minus 5 equals 2y plus 8. I'm going to subtract 2y to both sides, and I'm going to add 5 to both sides. 3y minus 2y leaves me with y equals 13. All right, Now we are going to use parallelograms with vectors. A vector is a quantity that both has a magnitude and a direction. And we are going to use parallelograms in vector diagrams. You see vectors a lot with like airplanes. A velocity vector tells you the airplane's speed and direction. Okay, so in this example, this next one, um, we have both an engine thrust vector and then they also have to calculate the wind vector. So my engine thrust vector is going one direction and speed. My wind vector is going to come in and I need to add that in, and then I can use a parallelogram to help me determine what direction is my plane actually going to go into. My resultant vector comes from my wind current vector and the engine thrust vector. The resultant vector is a single vector that will combine the two, and that's combining them using a parallelogram. So to determine where my resultant vector is, I'm going to use my two vectors I have, and I'm going to copy them down. And now my new resultant vector is going to be my diagonal. So that is the direction. The green one is the direction that my plane will actually go, encountering the wind and the engine thrust. You'll also see vectors used in ships and boats. They go one direction, but then the current has them going a different direction. So you can use vectors to calculate where they're actually going to end up. All right, so here's your assignment. You will see needing the parallelogram properties and about the resultant vectors. See you guys later.